Good morning, students. Now, I am to discuss today the magnetic lines of force, because you all know that we have started magnetism, right? And I also told you that a lot of things in magnetism is very much identical to our electrostatics. I have told you about the magnetic dipole and the magnetic dipole moment. Alright, today our discussion is magnetic lines of force, right, which is very much identical with electric lines of force with a small difference. At few places you will get small differences. Anyway, we shall see what are the differences. First of all, it was discovered by Michael Faraday, a celebrated physicist of London. And in this, what is magnetic lines of force? Magnetic lines of force are actually the curves which start from the North Pole and end at the South Pole outside the magnet. So, and inside they run from south to north. But first of all, I say that magnetic lines of force are the curves, so that the tangent drawn at any point of this curve gives the direction of magnetic field intensity. I repeat, just like the electric lines of force, magnetic lines of force are the curves. Okay, these are the curves, so that if a tangent is drawn at any point of which, the direction of this tangent will give the direction of magnetic field intensity at that point. Means, if I draw here, see, it is always been from north to south like this. If I draw a tangent here in this at the point P, let us say, then this is giving us BP vector, means magnetic field intensity at the point P. It is giving us the direction of magnetic field intensity at the point P. Followed? This is called, such type of the curves are known as magnetic lines of force. Moreover, we can also say magnetic lines of force are the curves which follow the path along which a magnetic North Pole will move if it is free to do so. Try to follow me what I am saying. In other words, we can say magnetic lines of force are the curves, right? These are the curves along which a magnetic North Pole will move. Magnetic North Pole will move if it is free to do so. Obviously, magnetic North Pole is not free to move, but if it is free to move, okay, then it will follow that path. That is called magnetic lines of force. Alright? There may be the different magnetic lines of forces. Let us now see what are the important properties. First, magnetic lines of force originate from the North Pole and terminate at the South Pole outside the magnet. Okay? They originate from the North Pole and terminate at the South Pole outside the magnet, whereas they run from south to north inside the magnet. As shown. Second point here, look, these are the closed magnetic lines of force, are the closed curves, isn't it? Because they start from the north to south, again from south to the north. That is unlike electric lines of force. Number 3, two magnetic lines of force will never intersect each other due to the same reason as we have discussed in the electric lines of force. Because what we have seen in case of the electric lines of force, if the two curves intersect, then this will give us the direction of the magnetic field intensity at this particular point P, suppose, and at the same point we are getting another direction. Means at the same point there cannot be the two directions of magnetic field intensity, right, for a particular magnet. So the two lines of force will never intersect each other. Number 4, Magnetic lines of force start from and end on the surface of the magnet normally. Means it will start from here normally, it will end at here normally. Right, on the surface of the magnet. It will be starting from the surface of the magnet and it is ending on the surface of the magnet normally. Number 5. Relative closeness of magnetic lines of force. Understood? Relative closeness of magnetic lines of force gives us the strength of the magnetic field intensity. Relative closeness, I repeat, relative closeness of magnetic lines of force indicate the strength of the magnetic field intensity in that region. That means if in a particular region magnetic lines of force are very close to each other, there the magnetic field intensity is stronger. Whereas if at a place they are away from each other, very much away from each other, then they are weaker. Magnetic field intensity is weaker. I hope these few important properties, one more property just I add. 6th, magnetic lines of force have a tendency of longitudinal tension. That means they expand lengthwise and contract sideways. So they have a tendency to expand lengthwise, longitudinally. They have a tendency to expand lengthwise and contract sideways. I hope these whole things which I have said, I think you can make the notes of it. Right, I have told you very clearly, you can just study and you can make a notes of it. Fine. This is regarding the magnetic lines of force. That means after completing this magnetic lines of force, I just tell you one thing. It is very much clear that magnetic lines of force, in case of the magnetic lines of force, we have seen that direction of the magnetic field intensity will be away from the North Pole and towards the South Pole. It is just like electric field intensity. Electric field intensity was away from the positive charge and towards the negative charge. Similarly, here magnetic lines of force indicate, the direction of the magnetic lines of force indicates that the direction of magnetic field intensity, listen to me carefully, direction of magnetic field intensity will be away from the North Pole and towards the South Pole. Away from the North Pole towards the South Pole. Fine. This is all about the magnetic lines of force. Okay, now I want to use this concept of magnetic field intensity, its magnitude and direction. Just to fix up the direction of the magnetic field intensity, I have discussed magnetic lines of force. Now I want to use it where in case of to find out magnetic field of a bar magnet. You know bar magnet? Bar magnet may be considered as a magnetic dipole, because you know in a bar magnet the two poles are there. One is North Pole, another is South Pole. Here one is North Pole, another is South Pole in a bar magnet. Here as shown. Okay, separated by a small distance, that is a magnetic dipole, you know. And if I say what is its magnetic moment, if in the figure I have shown you a bar magnet, here is a bar magnet, that is a magnetic dipole. Here is the North Pole, South Pole, plus QM minus QM are the pole strengths. I hope I have told you before also. And the distance between them is 2L. This is called the magnetic length. 2L is here called the magnetic length. Okay, 2L is called the magnetic length. So what is the, in this case it will be behaving as a magnetic dipole. What is the magnetic dipole? I write dipole moment, which may also be called as magnetic moment. Is it twice L, Q, M. I have told you in the last class. You can study, you can check my previous notes. You will get it very easily. Followed? We have just introduced in this way, we have introduced the magnetic dipole like this. In the next lecture, I am finding out its magnetic field at the axial point.